Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0420 indicates a problem with the catalytic converter's efficiency in a Honda Civic from 2022 and newer models. This code specifically signifies that the catalyst system efficiency is below threshold, meaning that the catalytic converter is not effectively converting exhaust gases as expected. The primary components involved include the catalytic converter and the upstream and downstream oxygen sensors. The catalytic converter is located along the exhaust system, typically between the engine and the muffler, and it plays a crucial role in reducing harmful emissions. The upstream oxygen sensor monitors the level of oxygen in the exhaust before it enters the catalytic converter, while the downstream oxygen sensor, referred to as HO2S, Heated Oxygen Sensor 2, assesses its output post-processing. If the readings from these sensors indicate a fluctuation that exceeds the threshold, the Powertrain Control Module, PCM, triggers the P0420 code to alert the driver of a potential emission control issue. The error description for DTC P0420 focuses on the catalytic converter and its interaction with the secondary heated oxygen sensor, or HO2S. The catalytic converter's primary role is to convert harmful pollutants in the exhaust into less harmful emissions before they exit the vehicle's tailpipe. It is crucially located in the exhaust system, often situated after the engine and before the exhaust manifold. The secondary HO2S, which is used to monitor the efficiency of this conversion process, measures the oxygen levels in the exhaust after it passes through the catalytic converter. When the PCM detects that the fluctuation integration value of the HO2S exceeds a specified limit for a certain duration, it assumes that there is an issue with the catalytic converter's efficiency, leading to the storage of DTC P0420. This could mean that either the converter itself is failing, or there are problems upstream affecting its performance. The primary possible cause for DTC P0420 is poor quality fuel, which can lead to incomplete combustion and increased emissions that the catalytic converter struggles to process. Additionally, a failing catalytic converter itself can directly result in efficiency issues. When internal components of the catalytic converter degrade or become clogged, its ability to filter out harmful substances diminishes, triggering this DTC. Another potential issue could be faulty oxygen sensors, particularly the secondary HO2S. If this sensor is malfunctioning, it may provide incorrect data to the PCM, leading to a false indication of a problem within the catalytic converter. Therefore, it's essential to examine the fuel quality, check the functionality of the oxygen sensors, and inspect the catalytic converter for structural integrity before proceeding with repairs. When DTC P0420 is triggered, the most apparent symptom is the activation of the check engine light, CEL. This warning informs the driver that the vehicle's emission control system is not functioning optimally, which is critical for both compliance with emission standards and for engine performance. Additionally, the vehicle may exhibit increased emissions, which could lead to failing an emissions test. You may also notice a decrease in fuel economy, as the engine may work harder trying to compensate for the inefficiencies created by a malfunctioning catalyst. Furthermore, the vehicle might experience rough idling or hesitation during acceleration as the engine struggles with the exhaust flow. These symptoms highlight the importance of addressing the underlying issue promptly to avoid further damage and maintain optimal performance. The first step in troubleshooting DTC P0420 involves starting the engine and holding the engine speed at 3,000 RPM. This step is crucial as it allows the engine to reach a stable operating condition enabling the vehicle's exhaust system, including the catalytic converter, to function properly. While holding the engine at this RPM, it's essential to ensure that the vehicle is in either park or neutral if it's a continuously variable transmission, CVT, or in neutral for a manual transmission. This process should be continued until the radiator fan activates. This activation indicates that the engine coolant has reached its optimal operating temperature, essential for accurate testing. Once the fan engages, it's time to shift to the next step of the confirmation procedure, where the vehicle will further be evaluated under various driving conditions. It is crucial to observe the engine's performance during this stage. In this step of troubleshooting, you need to test drive the vehicle under specific conditions to evaluate the performance of the catalytic converter further. The temperature of the engine coolant, monitored through the engine coolant temperature ECT sensor 1, should be above 158 degrees Fahrenheit, 70 degrees Celsius to ensure that the vehicle is functioning correctly. The vehicle should be driven with the continuously variable transmission, CVT, in drive or the manual transmission in either 4th or 5th gear at speeds between 45 to 75 miles per hour, 70 to 120 kilometers per hour, for a minimum of 5 minutes. This procedure helps the PCM gather data on how the catalytic converter responds to typical driving conditions. Following these guidelines is essential for gathering accurate diagnostic information to determine if there is a persistent issue with the catalytic system. The third troubleshooting step involves performing a deceleration test to monitor the vehicle's exhaust performance and sensor outputs. The driver should maintain the vehicle's speeds of 55 to 75 miles per hour, 90 to 120 kilometers per hour, for a minimum of 10 seconds, and then carry out a full throttle closure for deceleration. This test must be repeated 3 or more times to ensure the PCM can accurately capture the changes in sensor data and the reaction of the catalytic converter. During these deceleration events, the downstream oxygen sensor readings will reflect whether the catalytic converter is functioning correctly or still exhibiting inefficiency that warrants further investigation. It's crucial to perform this step diligently, as the fluctuations in sensor readings during deceleration will help confirm or deny the effectiveness of the catalytic converter in processing exhaust gases. Next, the fourth step requires maintaining the vehicle speed at 55 miles per hour, 90 kilometers per hour, for at least 4 minutes utilizing cruise control. This part of the troubleshooting process is critical, as it allows for a stable driving condition where the PCM can effectively monitor the outputs from all sensors, particularly the downstream HO2S. Cruise control enables a consistent velocity, reducing driver influence on engine performance and facilitating a clearer analysis of system behavior. It's essential to maintain this speed because it helps the PCM gather specific data that can indicate potential issues with the catalytic converter or related sensors. Monitoring the vehicle's response during this steady-state operation can provide meaningful insights into any additional faults or irregularities in the system. The fifth step involves closely monitoring the HDS or Honda Diagnostic system for any indication of DTC P0139. This Diagnostic Trouble Code specifically relates to the secondary HO2S and indicates that there may be an issue with that sensor's performance or effectiveness. Checking the OBD or onboard diagnostics status for this code is paramount, as it can help pinpoint whether the problem lies solely with the catalytic converter or if the HO2S is malfunctioning, causing the PCM to erroneously trigger DTC P0420. If the status shows passed, the vehicle may be functioning properly, but if it does not, follow the confirmation steps for DTC P0139 to address the problem. Solving this code will likely clarify the root cause of the initial P0420 code and may involve further steps like inspecting the wiring or replacing the secondary HO2S. After performing the necessary repairs, it is essential to conduct a final repair verification process. This step begins with a thorough re-inspection of all related components, particularly those that were replaced or adjusted. Ensure that the catalytic converter and associated exhaust components are in optimal condition, as well as verify that the upstream and downstream oxygen sensors are functioning correctly. Once you are satisfied with the checks and repairs, clear any stored Diagnostic Trouble Codes, DTCs, using the diagnostic tool. Following this, retest the vehicle under the same conditions used during the initial troubleshooting stages, allowing the PCM to reevaluate the performance. Observing the status of DTC P0420 and the response of other related sensors during this retest will confirm whether the repairs were successful and if the catalytic converter is now functioning efficiently. Preventive maintenance plays a crucial role in avoiding the recurrence of DTC P0420. One of the most important measures is the use of high-quality fuel, as subpar fuels may lead to improper combustion, increased emissions, and potential damage to the catalytic converter. Selecting fuel that meets industry standards can significantly enhance the longevity and efficiency of emission systems. Furthermore, regularly inspecting the exhaust system, including the catalytic converter and oxygen sensors, can help detect issues early before they trigger diagnostic trouble codes. Routine maintenance should involve checking for leaks, corrosion, and blockages. Performing regular engine tune-ups, changing air filters, and maintaining the fuel system can also optimize performance and prevent problems from emerging in the first place. In summary, DTC P0420 signifies a decline in the efficiency of the catalytic converter in a Honda Civic 2022 and later models. Understanding the roles of the catalytic converter and the HO2S sensors is critical for effective troubleshooting and repair. It's vital to monitor the secondary oxygen sensors closely, as their performance directly impacts the detection of this code. Regular maintenance activities, like using quality fuel and frequent exhaust system inspections, can significantly reduce the likelihood of facing such issues. By following systematic troubleshooting steps, including testing engine performance and monitoring diagnostic data, mechanics can ensure that repairs are effective and that vehicle emission standards are met. Timely actions combined with preventive measures will help maintain optimal vehicle performance and reduce environmental impact. Please like and subscribe to the channel. See you next time.